Welcome to another edition of Common Algebra. This video is for Algebra 1, Chapter 2, Section 8, Eliminating Fractions and Decimals. So in this section, we're going to learn how we can clear up things in an equation that make it difficult for us to solve. If an algebraic equation has a whole bunch of fractions in it, we'll learn a skill, a tool we can use to get rid of the fractions to make our life easier. And the same thing with decimals. So first, I guess I just put this in a list format. When we want to solve equations that contain fractions, the easiest thing we can do is to make the fractions go away, is to get rid of them. And we have some steps that we follow to do this. First, we inspect all the denominators we have to deal with, and we find the LCD, or the least common denominator, looking at all the denominators located in the algebraic equation. Once you find that LCD, you use it as a multiplier, and you multiply both sides of the equation by this denominator. Perhaps a better way for me to say this is you multiply every single term by that common denominator, every term. If you don't multiply the denominator through by everything, you have destroyed your equal sign, destroyed your equation. After you do this, after you multiply through, if you chose the common denominator, you will have no fractions left. And then step 3 is just like we've done in the whole previous part of this chapter. We just solve it with our undoing method, doing distribution, combining like terms, adding and subtracting to both sides, multiplying and dividing on both sides. And then it's a good idea to check your answer back into the original just to make sure that you did it correctly. I think these steps will become more clear after we've looked at a couple examples. This next table is a bit Captain Obvious, but you're responsible for knowing this. This is kind of like common knowledge. You're familiar with the coins listed here, and you need to know that their value in dollars is 0.01 and so on. When we do coin problems, a lot of times we'll use the first letter of the name of the coin. Like I'll use N if the problem is talking about nickels, Q for quarters, and so on. But if you don't write down anything else from this table, I think this is the most important column here. When you're doing coin problems and you need to have a value equation, in other words, you have so many dollars in coins, this is how we use the variables together with the value of the coins to work in an algebraic equation. For instance, the number of nickels is N, and so the value we have, the amount of money we have in nickels, is 0.05 N. So I would recommend writing this column down if you don't write down anything else from this table. We are going to refer to that in one of our examples. Let's go through these steps now in solving this algebraic equation that has some fractions in it. So step 1, we are figuring out what the least common denominator is relating all the fractions in this problem. So we have two denominators, a 4 and a 3. So the common denominator is like 3 times 3 is 9, but in this case 3 times 4 itself is the common denominator. So after we have found that, we're going to take this 12 and I'm going to actually put it into this equation by multiplying every single term in the equation by 12. So this, I just spread it out a little bit so I have some room. So this first term is going to be multiplied by 12. This x is going to be multiplied by 12. This 1/3 is multiplied by 12, and likewise on the other side of the equal sign, this 3 is also multiplied by 12. Like I said, what you do to one term, you have to do to all of them to keep the equation equal, otherwise you've destroyed your equal sign. And you'll also notice when I was multiplying the fractions by 12, did you see that I put it into the numerator? And if you put the 12 down in the denominator, you are in essence dividing by the 12. But we wanted it to multiply. And now if we chose our least common denominator correctly, and now we do the step that sometimes I refer to as do the math. And if we do the math now, all the fractions should be gone. So this 12x over 4, go ahead and do what is 12 divided by 4, and that turns out evenly, it's 3. 12 times x is just 12x. Keep the minus sign. 12 divided by 3 is 4, and 3 times 12 is 36. Now take a look at this equation compared to the original equation up here. This one looks a lot easier to work with. We can handle it. These fractions would have made a lot more work. So by using this strategy, you really are making your life easier, and it's a handy tool to have to pull out of your toolbox and use it when you want to simplify an equation. So now we just solve it as usual, combine like terms, add a 4 to both sides, continue over here, divide both sides by 15. So x is 40 over 15. This is a fraction that can be reduced, so we're going to reduce it by 5, and we end up with a final answer of 8/3. Let's look at example 2. Now what's different here is that we have some binomials in the numerator. In other words, we have x plus 2. It's a two terms in our numerators. And my advice, when you see this, go ahead and put your numerators in parentheses so that we honor that numerator, and we cannot break them apart. The x plus 2, you cannot break it apart and reduce the 2/6 or something like that. So put that in parentheses, and let's now go ahead and find our least common denominator. So scanning across here, we have 6 and 3 and 9, and they all go evenly into 18, so that's what I'm going to use as my common denominator. I'm going to multiply this fraction by 18. I'm going to try to sneak this one in here. I should have left myself a little more room. Multiply that one by 18 and multiply this by 18. So I had 3 terms and I multiply them all by 18. And now this is the step that I call do the math. What is 18 divided by 6? It's 3. So that divides, the denominator divides away, but we still have our numerator in parentheses. Keep the parentheses so that you see the distribution, otherwise it might be lost. Then we have a negative sign. Again, do the math. 18 divided by 3 is 6, and I still have the numerator in parentheses. Over here, 18 divided by 9 is 2. Again, doesn't this look a lot easier to solve than what we started with? So go ahead, do the distribution, combine like terms, subtract a 12 from both sides, and divide both sides by the -3. So my answer is -10 over -3, but this reduces. A negative divided by negative is a positive, so this reduces to 10/3, and that's my final answer. The other skill that is taught in this section is if you have an equation that has decimals in it and you want to get rid of the decimals, you can do so by multiplying by either 10 or 100 or 1000 depending on how many digits you have after the decimal point. So in this problem, here we just have 1, but since we have 2 digits after the decimal here and here, if we multiply this equation by 100, I'm going to show you this a different way. Multiplying by 100, the decimals will be gone. Now, when I put the whole thing in brackets here, this is distribution multiplying that term by 100, the 12.24 by 100, and this side is all one term because it's all connected by multiplying. So we got to multiply the 0.27 times 100. So if we do this, we would end up with 260x plus 1,224 equals 27 times, in parentheses, x minus 6. Not a huge amount of difference, a little bit. If you would have preferred to just go ahead and do problem 3 and deal with the decimals, I'm fine with that. This is just an option you have. Later on, it's going to become handy when we do want to get rid of the decimals when we're solving for many different variables. So just be aware of this skill, and we'll use it later. Of course, the first step here now is distribution. And we want to get our x's on one side, so I'm going to subtract a 27x from both sides. And if I subtracted that correctly, I got 233x. And then I'm going to subtract a 1,224 from both sides. And if I did that correctly, I got a minus 1,386. And then we just divide both sides by this 233. And of course, I would pick up my calculator. And I got x is equal to negative 5.94849. It's a long decimal. So let's just round that off, that x is approximately equal to negative 5.95. In doing this example, you will see why we wanted to talk about the value of the coins. A money box contains only dimes and quarters. It has 3 times as many quarters as dimes. So we want to pick the x here to be the item that we know nothing about. We know that it has 3 times as many quarters. So the dimes here are what we don't know. So we're going to let x equal the number of dimes. And we are told again that there's 3 times as many quarters. Well, 3 times x is written 3x, so that's going to be our number of quarters. We are told that the money totals $17. So we can't just add x and 3x and say that that's 17, because x is just the number of dimes. If we want to turn this number of dimes into money, that's when we have to use 0.10 times x. Now this is the number of dimes times 0.1, which would give us dollars. So now this is a value. So we have the 0.10 times x. We have 3x for our number of quarters, and we know that a quarter is worth 0.25. So we want to multiply that times the quarters, which is 3x. And now this will come to total $17. So we need to solve this. 0.25 times 3 is 0.75x, and that equals 17. And we go ahead and add 0.10 and 0.75, and we get 0.85x equals 17. And then if you divide both sides by 0.85, you get x is equal to 20. So now to answer the question, how many of each coin? Well, we know over here that X was the number of dimes. So there was 20 dimes in the box. And the other thing we knew that there was 3 times as many quarters. So 3 times 20 is 60, and now we know there was 60 quarters. All right, now you have the knowledge you need to do section 2.8. So have fun.